Okay, so welcome to the ninth day of the chapter 6 chemical thermodynamics. Okay, today is a Tuesday, 23rd of November 2021. And there are some more numericals based on this chapter, chemical thermodynamics, which I would like to discuss today and try to complete the numericals today to end the chapter. Okay, tomorrow I'll be starting with states of matter, gases, and liquids. Now, in the meantime, when the boys are joining, I'm going to write down the questions. Okay. The first question for today. You may, please write it down. Okay. A sample of gas is compressed at a pressure of 0.5 atm from a volume of 400 centimeter cube to 200 centimeter cube. The gas is compressing. It is being compressed by an external pressure. Pressure is 0.5 atmosphere. The volume is decreasing from 400 to 200. Now, during this process, 8 joules of heat flows to the surroundings. Flows to the surroundings. Surroundings. Calculate the change in internal energy that is we are supposed to find delta U, energy of the system. That is the question. Okay. I read the question once more. A sample of gas is compressed. It is compressed at a pressure of 0.5 atmosphere. The pressure is, I think it's kept constant over here, external pressure. Okay. The volume, it is being changed from 400 to 200. It is an irreversible work. Isothermal, irreversible work. The temperature is constant and the work done is irreversible work being done on the gas. And during this process, 8 joule of heat is given out, flown to the surroundings. So the heat over here, the heat it is Q. The value of Q it is -8. Negative sign has to come over there in the formula. Okay. So solution you have to write down over here like this. For isothermal irreversible work done. Irreversible work done. The formula is like this. W is equal to minus P, pressure, this pressure, and we write it external pressure, and volume 2 minus volume 1, delta V, no? So that is V2 minus V1. So if you put the values of pressure, that is minus 0.5 Put the values of pressure minus 0.5, and volume 2 is given as how much? Final volume is how much? What is the final volume? Tell me. The final volume. What is the initial volume?
So 400.
Final volume.
So 200.
So 200. No. Now this, it is converted into, because we are using pressure in atmosphere, we convert this centimeter cube into liters. So it becomes this 200 divided by 1000, it becomes in liters. So 0.2, because pressure is in atmosphere, so convert the centimeter cube units into liters. So 0.2 minus 0.4. So here I will get, upon simplification, 0.2 minus 0.4, and there is a minus sign in the front. Minus and minus will cancel. 0.2 into 0.5 will come 0.1 atmosphere liter. So this is the work done which is given. Okay. Now this work done, it has to be converted into joules. It has to be converted into joules. So I'll multiply this 0.1 atmosphere liter by 101.31 to get to convert this atmosphere liter into joules. So I will get, if I multiply this, I will get 10.131, 131 or 13, yeah, 131 is okay, 131 joules. That is the work done. Okay. After we get the work done for this isothermal irreversible, okay, process, then I will use the first law of thermodynamics. So we know from the first law of thermodynamics, first law of thermodynamics, that the internal energy, the formula is Q plus W, work done. So we are supposed to find delta U, capital U. Okay. Now Q, it is given in the question as 8, and it is given, though this heat is flowing to the surroundings. So minus, so here it becomes minus 8 plus W we have calculated 10.131. So upon simplification, this becomes positive 2.131 joules. That is the answer. Okay, so this is the internal energy of the system. Internal energy of the system. Okay, 2.131 joules. It is a positive value. Now, this is one question for today. First question for today. Let us go to the next question. Question number 2. Question number 2 for today. I'm writing the question on the screen. Please follow. Swimmer, SWIMMER, swimmer coming out from a pool is covered with a film thin film of water weighing 18 grams. So as soon as you come out of the swimming pool, okay, in your swimming trunk, okay, there will be a layer of water, thin layer of water on your body. So that is what is happening over here, and the mass, the assumed mass of the water that is covering the body, it's, for this question, it is 18 grams. It is how much? 18 grams. Now the question is how much heat heat must be applied must be applied must be applied to evaporate evaporate this water at 25 degrees Celsius, or we can write down 298 Kelvin. Question mark. That is, you have to find the heat which is supplied, and the other part of the question is also calculate also calculate the internal energy of vaporization. Also calculate the internal energy of vaporization at 100 degrees Celsius. Okay, and then what is given? The enthalpy of vaporization, the standard enthalpy of vaporization for water, for water, for water at this 373 Kelvin. It is given 40.66 kilojoules per mole. Okay, that is given. This is given. Okay, so try to imagine this question. Okay, a swimmer is coming out from the pool. Okay, of course the pool contains water. Okay, and when he comes out of the pool, his body is covered with a thin film of water weighing 18 grams. So the mass of water is given, which is on the surface of his body. So how much heat must be supplied to the surface of that swimmer, so that all this water, 18 grams of water, it evaporates easily, conveniently at 298 Kelvin. And moreover, we're supposed to calculate the internal energy of evaporation of water at 100 degrees Celsius. That is the question. Okay, so solution part. Copy down the question so that I'll remove this slide and go to the next slide. For the solution part, it is always advisable to write down information given. 18 grams of water, no? Liquid state. It is being converted, vaporization. It is being vaporized to 18 grams of water vapor. Okay, this is the main thing over here. Now, to get the enthalpy over here, to get the internal energy or internal energy of vaporization, we need, it's very important to uh, get the number of moles of 18 grams of water which is in the liquid state. So the next thing we are supposed to calculate is get the number of moles in 18 grams of water in the liquid state. So it is given 18 grams and then its molecular mass is 18. So it is coming easily 1 mole. Number of mole is 1 mole. Then we apply the formula for internal energy, delta U vaporization. Delta U vaporization. Okay. VAP. VAP vaporization is equal to delta H. This is given minus pressure volume work P delta V. Or we can write down delta H naught vaporization minus P delta V is converted. Delta V is converted over here into delta H gas RT, assuming that steam is an ideal gas. So here, if you assume the steam to be an ideal gas, then this delta V becomes RT. Okay, delta Hg comes over here. Okay, then internal delta U vaporization will be equal to, over here it is given 40.66 minus 1 mole. Okay, nRT, 1 mole over there, gas constant is 8.314 into 10 to the power of minus 3 into temperature is 373. Okay, so we have got this. Upon simplification, we get the value of internal energy as 37.56 kilojoules, sorry, this one is kilojoules per mole. So this is the answer for both the amount of heat supplied and the internal energy of evaporation at 373 Kelvin. So this is the answer for both the question. Okay, assuming steam is behaving as an ideal gas. Okay, so practice this one also. Okay, okay, this question is I have taken it from one of the competitive examinations. Okay, and it has been asked in the class 11 final term examination also. Then moving to the next question, question number 3. Question number 3. Question number 3. The question is certain reaction, a certain reaction, a certain reaction is non-spontaneous, non-spontaneous at 298 Kelvin. It is non-spontaneous. It is not feasible. The the entropy change during during the reaction is 121 joules per Kelvin. This is the entropy change. Now the question they are asking is the reaction is the reaction is the reaction endo or exo? Endo means endothermic or exothermic. Exothermic. Okay, that is the question, first part of the question. Now the other part of the question is what is the minimum value? What is the minimum value? Minimum value for of delta H. What is the minimum value of delta H for the reaction? For the reaction. So the question you can see on the screen. What is the minimum value for delta H for the reaction? Okay, I hope we are connected. I believe there was some network problem just now. Okay, I think we are connected only. So this is the question. Okay, so what is the minimum value of delta H for the reaction? A certain reaction is given, it is non-spontaneous at 298 Kelvin. So for the solution part, remember it is given delta G for a non-spontaneous reaction, delta G is positive. So we can write down given delta G is positive for non-spontaneous reaction. Okay, and then we can apply the formula delta G is equal to delta H minus T delta S. Okay, temperature 298 Kelvin. Okay, so here moreover the entropy change is given, delta S को value is given plus 121 joules per Kelvin. Okay, now here please note that remember that delta H has to be positive. This delta H has to be positive. So we write it down. Delta H has to be positive. delta H has to be positive, that the reaction is non-spontaneous. Non-spontaneous. Okay. So to make delta H positive, delta H also has to be positive. So therefore, to calculate, so to calculate the minimum value of delta H, delta G will be 0. Okay. Minimum value of delta G has to be 0. That means somewhere at equilibrium. Therefore, we can say delta H must be equal to T delta S. So therefore, delta H will be equal to temperature is 298 Kelvin into delta S. The value is given 121. So upon simplification, we get 36.058 kilojoules. 36.058 kilojoules. That is the answer. So this reaction is, it is a non-spontaneous process. So of course it is an endothermic reaction. Remember that it is an endothermic reaction. Okay, it is an endothermic reaction. It requires heat, and the minimum value of enthalpy change for the reaction is found to be 36.058 kilojoules. Positive value is there. So it's an endothermic reaction. It is an endothermic reaction. Okay, so that is question number 3 for today. Okay, so try to practice this properly. These sums are important sums. Now we go to the next question, number 4. Number 4, the fourth question. Fourth question. I'm writing the question. What is the what what is the equilibrium constant? Equilibrium constant. What is the equilibrium constant? That is Kc. Kc for the reaction given below at 400 Kelvin. Okay, and the reaction is given nitrosyl chloride to NaCl gas. It's a reversible reaction. Okay, it is forming NO, nitrogen monoxide, plus chlorine gas, Cl2. And delta H, the enthalpy change is given 77.2 kilojoules, and entropy change, standard entropy change is given 122 joules per Kelvin. The temperature is of course at 400 Kelvin. Okay, this is given. Now for this question, we have to find the equilibrium constant. To get the equilibrium constant, first we have to get delta G. So we have to use what over here? The Gibbs-Helmholtz equation. So according to Gibbs-Helmholtz equation, we have delta G naught is equal to we have delta G naught. Okay. Delta G naught is equal to delta H naught minus T delta S naught. Okay, this is the Gibbs-Helmholtz equation. Okay, now putting the value delta H value is given 77.2. We'll use in kilojoules only. 77.2. Okay, minus temperature is 400, and convert this 122 joules into kilojoules. So it become 122 divided by 1000, or you can write 122 into 10 to the power of minus 3. Okay, So upon simplification, this comes around approximately 28.4 kilojoules, or we can write in joules also, 28.4 into 10 to the power of 3 joules. This is the value of, it's a positive value. It's a positive value for Gibbs free energy change. Okay. Now we'll apply the relation equation. Delta G naught is equal to minus 2.303 RT log to the base 10 Kc. Okay. So we are supposed to calculate Kc. So therefore log Kc, Coulomb constant to the base 10 over here, will be equal to minus delta G naught. This minus sign is going this side, divided by 2.303 RT. Okay. So putting all the values, delta G naught value we have already calculated. It was in joules, 28.4. 28.4 into 10 to the power of 3 divided by 2.303, and gas constant we take it as 8.314, and temperature is 400 Kelvin. Okay. So we're getting log to the base 10 Kc. If you simplify this, you will get minus values there. You get you get 28.4 10 power of 3 divided by, open the bracket, 2.303 into 8.314 into 400, close the bracket. It is coming minus 3.7081. That is negative value. So we're getting Kc. Kc, to get Kc, equivalent constant, anti-log of minus 3.7081. Now let us see whether the value of Kc is high or low. So Kc, it comes to 1.958 into 10 to the power of minus 4. No units. Okay. So that is the value for equilibrium constant. It is a low value. It's not a high value. It is a low value. That means the reaction is not feasible, not so spontaneous. Okay. It is not so spontaneous. It is at equilibrium. Okay. So that's the answer for equilibrium constant. So that is the fourth question for today. Okay. Look at the working. We first got delta G naught. Okay. And then we apply this equation. Okay. And then putting the values, get the value of KCC, how the working is done. Then question number 5 after this. Question number 5. We will do question number 5. The equilibrium constant. Next question. The equilibrium constant Kc for the following reaction. For the following reaction is 5.62 into 10 to the power of 35. Spontaneous, high value, big value, at 25 degrees Celsius. The reaction is given below. CO, carbon monoxide, plus Cl2. Cl2 gas. It is forming COCl2, phosgene, COCl2. It is also a gas. Okay, now the question says calculate the Gibbs free energy change for the formation for COCl2 at 25 degrees Celsius, given that the free energy change for the formation of carbon monoxide, it is minus 137.3 kilojoules per mole. Okay, and the Gibbs free energy change for chlorine is a molecule, it's an element, so that is 0. Okay, now solution for this question. We write down the equation. Delta G naught is equal to 2.303 RT log to the base 10 Kc. We write this equation and put all the values. And first get delta G. So delta G naught is equal to, in the formula there is minus, so minus 2.303 R को value I will take 8.314 into temperature, it is 25 degrees Celsius. So 25 plus 273 is 298 Kelvin. 298 Kelvin into log to the base 10. Kc का value is given 5.62. So 5.62 into 10 power of 35. Okay, so upon simplification by using a scientific calculator, first get log this one and multiply it to 298, 8.314 and 2.303. So this one, if I simplify it, I will get the free energy change for this reaction as value, it is coming to minus 203.98 kilojoules per mole. Okay, that is the value of delta G naught. But they're telling us to find the equilibrium constant, equilibrium constant at 25 degrees Celsius AC. Calculate the value of delta G naught formation for COCl2. So now we'll apply the other equation. Now delta G naught is equal to delta G naught for the formation of COCl2, okay, minus delta G naught for the formation of CO, carbon monoxide. Okay, this in brackets. So this will apply over here. This value we already got, minus 203.98 is equal to, now we're supposed to find this. So delta G naught for the formation of COCl2, we don't know, that is what we're supposed to find, and this value has been given in the question. So minus 137.3. Just check. It is given minus 137.3 kilojoules per mole. So we'll put this value over here. And therefore, we rearrange and simplify. Delta G naught for the formation of COCl2 comes to this plus minus 203.98. This minus is plus. It will become minus over here again. Okay. Minus 137.3. So upon simplification, we get minus 341.28 kilojoules per mole. So this is the delta G naught. This is the Gibbs free energy for the formation of COCl2, carbonyl chloride. Okay. This was question number 5. Question number 5 for today. Okay. So please follow the steps. This step will help you in answering your what you call multiple choice questions. They might give you variety of answers. The correct answer is this one. They might write 345 point something. They might write 340 point something, 339 point something. So these answers are very close. So you have to simplify, get the answer, and then tick the correct option. Select the correct option in your examination. Okay. So this was question number 5. Okay. Then we can do some more reactions, some more questions. One more question I think we can do. That is time. Question number 6. Question number 6. Okay. Uh, calculate the enthalpy change for the reaction. Now the reaction is given over here, carbon, which is in the form of allotrope graphite, okay, plus It is reacting with hydrogen gas. It is forming methane gas. Okay, methane gas. Then what is given? Given that, equation 1, graphite, graphite plus the combustion of oxygen. What do you call this graphite? It is forming carbon dioxide, and here delta H naught for this reaction, for the formation of carbon dioxide, it is minus 393.5 kilojoules per mole. Kilojoules per mole. Okay. Then equation 2, hydrogen gas plus oxygen gas, it is forming water in the liquid state, and the enthalpy for the formation of this reaction for water, it is minus 285.8 kilojoules per mole. Okay, this is given. And there is one more equation that is given for the combustion of methane, CH4 plus oxygen. It is forming carbon dioxide now, carbon dioxide gas, okay, plus water vapor, okay, water vapor or water we can take liquid after condensation. The enthalpy for the formation of this reaction is given as minus 890.33 kilojoules per mole. Okay, this is given in the question. Now they're telling us to calculate the enthalpy change for this reaction for the formation of methane. So now we have to work out diligently over here. We have to think what can be done with these three data which is given. So to obtain the delta H for the above question, what we have to do is, equation 1, you add equation 1 and equation 2. Equation 1 and equation 2 you add. If you add them, okay, and then from that you subtract twice equation 3. So I am writing in short. Equation 1 plus equation 2, subtract twice equation 3. Subtract twice equation 3. So you add equation 1, equation 2, and then from that you subtract 2 times equation 3. If you subtract 2 times equation 3, then that serves our purpose. So equation 1, it is minus 393, minus 393.5, minus 393.5 kilojoules per mole. Okay, 393.5 plus over here, and then 2 times minus 285.8 minus 890.3. The second equation is also multiplied by 2, so we put over here 2 because we have to balance it and cancel, because here there is 2 water, so you have to multiply the second equation also by 2. Okay, remember that the second equation also multiplied by 2, adding this 2 and subtracting equation 3. Okay, so here this 2 is not there. Okay, this 2 is not there because CH4 plus twice O2 CO2. This CO2 is there, CO2 is there. Okay, they have to be added up and cancelled later on. Okay, so upon simplification we get delta H value. We get negative value minus 74.8 kilojoules per mole. That is the answer. So this is one problem. This is one numerical based on the laws which we have learned. SS law of constant heat summation. So we are using that concept of we have to solve this numerical. So try to practice such questions for your examination. That will help you a lot. Okay.
Sir,
Yes.
sir, this was SS law, or what law did we use?
We are applying SS law because
Yes, sir.
we are to get the value of delta S. So we are adding all this, no? Because ultimately the final equation is this one, no? Carbon plus 2 hydrogen is giving CH4, no? So to get
Yes,
this
sir.
equation, we are applying SS law in this step over here, this step. Okay. Now to get this step, we have to add equation 1 plus twice equation 2 minus equation 3. Twice equation 2 minus equation, because in equation 3, carbon dioxide 1 over it is 1, isn't it? So if you subtract, this will cancel, no? Carbon dioxide will cancel this one. So water will also cancel. Okay. Methane will remain, hydrogen will remain, because we have multiplied this equation by 2, no? And this oxygen will also cancel because there is a subtraction sign over here, no? So that's how we get the answer minus 74.8 kilojoules per mole. Okay. So that completes our numericals from this chapter, that is chemical thermodynamics. Okay. Now with this, I would like to end the chapter here only, and in tomorrow's class, from tomorrow, I am getting three more classes. One, two, three, four classes from tomorrow. In that four classes, very briefly, I shall be touching the important topics and subtopics in the next chapter, that is states of matter, gases, and liquids. Okay, that's an easy chapter. Even though it's an easy chapter, I'll just discuss very quickly. I'll try to summarize things in a proper, presentable manner tomorrow, and then I will present to you and try to explain the basic important points from the chapter. Okay, so with this, I like to end my class here only. But before that, I will record the attendance for today. Okay, please stay on over there. Attendance is it's downloaded. Okay, it is downloaded, boys. Thank you so much. Thank you so much, boys, and have a nice day.
Thank you, sir. Same to you.